Hi guys, so here is the homework for today. As it mentions on the paper, I'm going to be solving this problem in two different ways. So please be sure to write down both ways on your paper. Alright, so suppose that water is draining from a conical tank such that the height of the water level is changing at a rate of negative 0.2 feet per minute and the radius is changing at a rate of negative 0.1 feet per minute. What is the rate of change in the volume when the radius is 1 foot and the height is 2 feet? Okay, so let's circle some keywords right now. So we suppose that the water is draining. I'm not quite sure. Sorry, here we go. Draining from a conical tank. All right, so conical is an adjective of the word cone. So that means that I have a cone-shaped thing and that there is, of course, water in it. Water. And water is coming out of the tank. So, of course, if the water is coming out of the tank, then the height is going down. And that is why the height of the water level is changing at a negative rate. Right? So if you're wondering why the height is changing at a negative rate, it's because the water is going out. So the height of the cone is also getting smaller and smaller. Now you can guess, right? If the water is going out, there's a lot of going out, then the height is getting smaller, and of course the radius is getting smaller because at the very beginning the radius maybe was this big and now the radius is this big. So the radius is also changing at a negative rate because that is also getting smaller. Now, what we want to know is what is the rate of change in the volume when the radius is 1 foot and the height is 2 feet. So let's think about this. Is the rate of change in the volume going to be positive or negative? Rate of change is going to be negative because the volume of the water, of course, is also getting less. So we know that we are looking for a negative answer. So let me start a new page and start kind of organizing our information. Alright, so I'm guessing that you have the problem in front of you, so I'm not going to copy down the problem again, but here is my picture, and as usual, let's write down our given and what we want to find. So here's my given, here's what I want to find. What I am given is that the height of the water level is changing. Okay, hold on, let me just label my picture first, right? So usually when we're talking about a cone, we have an R and we have height. So it looks like what it's saying is that dH over dt equals negative 0.1 feet per minute. And then it says, the radius is changing. Oh, I'm sorry. The height is negative 2 feet per minute. It's a 2. And then it looks like the radius is what is 0.1 feet per minute, negative 0.1 feet per minute. Okay, equals negative 0.1 feet per minute. Okay, so what is the rate of change in the volume? So we know that the volume is going to be dV over dt. I know the units for that are going to be feet cubed per minute because it's volume. And I want to know that when the radius equals 1 and height equals 2. Excellent. So that is my given and find. So I'm going to pause for a moment and get some more room to work the problem. All right, here we go. So
Of course, the equation that we're going to be using is V equals 1/3 pi r squared h. And we know that because we are working with the volume of a cylinder, volume of a cone. So if we want to take the derivative of this, then hopefully you can see that what we are dealing with is a product, right? So there is actually a product of 1/3 pi r squared times h, right? So if we are using the language of f of x and g of x that we've been using before, then this would be like our f of x, right? And this would be our g of x. So take some time right now to review the product rule in your notes if you don't have it, and hopefully you remember it. And let's use the product rule to figure out the answer. So if we are doing dv over dt, I feel like, hold on, let me move this over a little bit. Okay, so I'm doing dv over dt equals, so I'm going to leave the first part by itself, 1/3 pi r squared h, pi r squared, and then I'm going to multiply it by the derivative of g of x. So the derivative of h with respect to t is dh over dt. All right, I've got that. Plus the derivative of f of x. So that is 2/3 pi r times dr over dt. Okay, and then I'm going to multiply by the original gx function, so that's times h. Okay, so it looks like I have all of the numbers that I need to figure out what is going on. So I'm going to do, right, I have r, I have, let's just check really quickly. I have r, I have dh over dt, I have r, I have dr over dt, and I have h. All right, so I'm going to give you some time to plug this into your calculator, and hopefully you'll get the same answer that I do. All right, so hopefully by now you have plugged it into your calculator and you've got the same answer that I do, which is negative 0.628 feet cubed per minute. I'm going to write the answer on the next page, and I'm going to write it two different ways. This is not the second way that I talked about earlier, but I'm even going to write the answer two different ways, and I want you to notice what the difference is between the two ways. All right, so here is one way to write this answer is the rate that the volume is changing is negative 0.628 feet cubed per minute. So this is very similar to the way we've been writing it, so you might be like, this is nothing different. But look at what happens if I do it like this. If I say, the rate that, oh, I'm sorry, I wrote the. I meant to write that here. Okay, that the volume is, and here's a really important word, decreasing is, and look what happens to my answer. And pay close attention because it's going to be important tomorrow. I lose, or not lose, but I don't write the negative here. So if I write decreasing, then that already includes, that already tells people that that my rate is negative. So if you include the word decreasing, then you don't have a negative, no negative, right? It's just 0.628 feet cubed per minute. If you don't have
decreasing. You just tell people that it's changing. Then people don't know if it's increasing or decreasing, so you have to have that negative in front of your answer. So pay attention to this, because tomorrow we're going to have a problem where the way that the problem is stated might change whether you have a negative or no negative. All right, well, I told you that we were going to solve this problem 2 different ways. Here is the second method. Method 2. And remember, you should also have this on your paper. So, the second method is very similar, but a little bit different. It becomes a little bit easier as you're solving it, but a little bit longer for the setup. So, what we do here is we say, all right, so here's a cone. Here's the water level in the cone, right? And it's saying that right now, right, what is the rate of changing the volume when the radius is 1 foot and the height is 2 feet? Well, the thing is, in a cone, usually, not always, but in a normal cone, if the cone is not changing shape, now remember, not some problems the cone is also changing shape, but in this case, the cone is not changing any shape because it's a conical tank. The tank is not changing its shape. It's just that's the size, that's the shape of the cone. The radius and height are always going to be in the same ratio. So as you can see, if the radius is 1, the height is 2. Which means that the height is 2 times the radius, right? So that means when the radius is r, the height equals 2r. So what we're going to do is that is always going to be true in this case. Not always, but in this case. So what we're going to do is, in our original question, 1/3 pi r squared h, we're actually going to rewrite it in terms of r, right? So you can see I'm substituting the h equals 2r equation into h, and what I get is a final equation that only has r. I'm sorry, that should be a 2 pi r cubed, right? And so what I can do is I can actually now take the derivative of this, right? I'm going to take the derivative of this to find dv over dt. And when you do that, you're actually going to get exactly the same answer, negative 0.628, right? Now remember, this only works because we're talking about a conical tank, and the tank is not changing shape. This is not always true for all cone questions. But this is... let me just say again what we just did. We rewrote the equation in terms of r. And that just means that our final equation just has r and no h. Okay, so please write this down. If you have a chance, try to do this work by yourself, right? Try to take the derivative and make sure that you still get the exact same answer, which you should. But this part is also going to be important for our classwork tomorrow. Okay, so I hope that helps. I will be answering a few questions about this tomorrow if you have any. So make sure you kind of try to remember what your questions are as well. Okay, bye.